Good evening, everybody. It's 9 p.m. It's the 2nd of May, 2020, and it's Saturday. Let's get stuck in. Get away from that live music, despite how good it is. So, let's get the live stream going. Ding. There we go. You can see I've still got my spinning balls here. So today we're going to look at how we can make, how can we interact with the 3D objects on the screen. So I've done extremely quick bit of research on it, very, very quick, and I found this little nugget. Let's see. So how to turn a 3D object into a button. You can't, apparently. This is saying put an area into it. Godot button, but they are part of control, right? And canvas item. They're not really related to 3D scene. Godot buttons in 3D, this is no use. Put them under a canvas layer. That's if we wanted the buttons to hover over our 3D. And then I found this. Camera unproject position will return the 2D screen position of the 3D position. So presumably that is the position of the object we want to check. So let's just try this. So one more question. Is there also a function for getting the rectangle of the object on the screen? Oh, too late. That's a tricky one, isn't it? Because how big is the object? All we're looking for is there. But that doesn't matter so much because we can get within a certain radius around it. So let's just see if we can get some sort of highlight over these. That is the goal. So we've got spinning objects, goody goody. We've got all this code we don't need anymore, but just comment it out for now. Control K. There's a shortcut for commenting out a chunk of code. Pretty handy. So, what objects have we got? We've got mesh instance number 1 to the left. So we're going to try and focus on that first of all. So let's take this little bit of code. Wonder if we can get like the mouse position on the screen as well. That would be the trick. But anyway, so let's just try this. So we want vector 3 of our mesh instance 1. So that would be mesh instance. Let's have a look at our properties over here. Now would it be translation? Yes, I think it would be translation. So it's just translation. So that should give us a vector 3. Non-static function, unprojected. Oh, of course, camera. Camera needs to be camera. Better? Yes. All right. Now we want to print that out. We should get an XY.
I woke up.
And it's going to change, right? Oops. It's
Dry.
going to change as I move my camera around because it's in relation to the camera position. So I move to the left. It moves to the right. So now the square. Oh, that's weird. Yeah, no, it's working. Yeah, so this cube here is currently 300 pixels in from the left side. Now, it's only 189 pixels in from the left side. So we are printing out a 3D vector in relation to the camera. So that should allow us to, if we can check to see what area the mouse is in, the mouse pointer, we should be able to say, oh, it's on that object, let's highlight it. So next thing we need to do is we need to get Godot, get mouse, viewport position. We get 3D. 3D position. Where's a 2D? Interesting. Yeah, we don't need that. I mean, what are we returning back there again? Let's have a look at our Yeah, it's an XY coordinate, right? It's a viewport coordinate. So we only need a 2D mouse and input coordinates. You get the mouse position from the viewport. How can you convert it to world position? Okay, I want to get the mouse position from the viewport. Is that what I want? You want the mouse coordinate relative to your canvas. Each node 2D inherits from a canvas item. It gives a method. Maybe that's what I want. I'm not sure. Because I think we're still going to want canvas items on the screen, right? Do we want everything to be clickable like this? Maybe we do. Maybe we do. I don't know. Also want to be able to float text on the screen somehow. Text in our world. Well, that's a good point, isn't it? Because now we've got this code here. That means we can actually float 2D objects into the world. So I could actually float a button, which means I could actually float text. It's going to be fun hooking all this up to the world. I'm looking forward to that day, that evening. I think it will take too long. What should I do? Should I try and hook a button up? Let's hook a button up. Just make it float next to our nodes. So let's look at our user interface scene. Our user interface code is by the by. It's our exit code that we want to see, right? So our exit code. No, it's not our exit code. It is our. Where do we put it again? Player? No. Oh, it's update GUI. That's what we want, isn't it? Which is going to be in game. Yep, there we are. Update GUI. So we've got a function called display exits. So we're going to kind of change this. So at the moment, we've put objects into the world. What we want to do next is introduce our objects to the world based on our exits. Why can't we do that now? Let's just do that, shall we? Let's hide our user interface. You know what? I think it would be a bit dangerous to do that now, because we're going to start down a dangerous path. Dangerous in that I'm not going to be able to commit to completing, and I want to get to as close as possible to understanding all the issues I'm going to face before I tackle the problem. So let's have a look here. We've got a few things we did here. Discard that. Okay. User interface, visible, false. What's that? I can discard that. Game script. I added a line. Discard that. Global. Play narrative. Discard that. Get rid of these. iPhone objects. And what are these? Let's see, iPhone imports, discard that. And not sure what I did here, but that's just the standard icon. So I must have done some sort of, oh, it's the 3D import. It's created some kind of 3D version of the Godot icon. Keep that. So now we've just got Spatial. All we're focused on, messing with Spatial. So let's look at our exit code. So at the moment we are looping through, creating buttons based on our objects. So our function update GUI does just that. And our update GUI is just run once on ready. So I'm going to create a new function here. Going to base it on the exit object. tunes. Okay, so display exits. I'm going to take that code. Now, should I start instantiating squares and cubes into our scene? Or shall I just try and... Yeah, I think I'll not do that yet. I'll paste this code in. I will... It'd be nice if you could, like... Oh, you can. Look at that. That's cool. I was going to say, I thought if I commented it in, I commented it out, all my comments would be uncommented. Obviously, just stacks them. So let's try and get our mouse pointer position. Work on that problem first. Easy to get carried away down the rabbit hole. So we'll try and get global mouse position. Let's print that out at the same time. So this is our mesh XY. And then we're going to print out our mouse. Moose XY. Skipping the E. Some of the text lines up. All right. Oh, what's this? Okay. Misplaced a built-in func. Let's have a look at this function. Control left click. Nope. Why does that not always work? There it is. Clickable. Right. Back to 2. So inherited from. It's inherited from a canvas. So we have to have a canvas on our screen here. Canvas, if you remember, is like a screen that we add our GUI to. So it inherits all sorts of useful functions. You can draw on it. You can put your buttons on it, your GUI objects. It's a load of stuff I haven't messed with in that. Pretty cool. Look, you can draw circles on it. Yay. Who needs 3D when we can just use this instead? Anyway, so canvas will be completely transparent. So we'll add a canvas. I wonder where I should put it. Because clearly, canvas layer wouldn't make sense to put it in as a parent to the spatial. It would be, I don't know. Maybe it is. Oh man, let's have a look. Let's just have a quick look. So, where to put canvas layer on 3D Godot. Canvas layer doesn't work if you put 3D objects under it. What? What? It's a canvas element that displays its child viewport. Place a camera in spatials under a viewport and make sure to tick own world. It's a canvas element that displays its child viewport. Place a camera and some spatials under a viewport. Own world means the scene inside the viewport won't take current lighting into account. What? Well, you know what? Sometimes you just got to try and see what happens. So let's just add a canvas layer. See what craziness follows. Canvas layer, stick it right up here. And, I mean, that should make a jot of difference, right? Ooh. My function doesn't work. That for now. Right. Makes no difference. Canvas layer is still there. So if we, for example, then add what can we add to the canvas layer that's obvious about a button? A button. there. Put in some text. Button. Right. Re-render our canvas layer. I mean, our 3D layer. There you go. So that's what I expected. You want to see this layer over the front. So what it's saying now is that I can get the position of the mouse in respect to the canvas layer, right? So I can go back and I can say print, shakes Y, and I pass in my canvas. Let's just check my canvas layer. Okay, let's get rid of our button as well. Don't need that. All right. We're passing. Oh, where'd my bracket go? Is that the problem all this time? Surely not. Isn't what's it? Something stupid like that. Nope, it wasn't. Oops, wrong button. Yeah, definitely isn't like that. So, here we go. Load. Happy days. Okay, so now. Nope, doesn't like that either. Let's look at our canvas. Oh, canvas item. What? All right. You know what? From what I read on that, getting the mouse position globally wasn't the best way, right? Let's just try that. There we go. Using hardware coordinates makes sense in the writing of complex UIs. Oh, right, yeah, of course, resolutions and things can change that. Doesn't matter though, right? Because we're going to be checking an area around the object. Right, look at that. Let's try it. We've already got an event handler in our spatial, right? So now we're saying if it's a click, oops. Tabs in there. If it's a click, then tell us the event position of the click. Could it be that easy? Non-existent function. Oh, we still got that in. Okay, looking good. So if I click here, it should be about the same, right? Indeed it is. It shouldn't matter what our resolution is. I'm not changing it here at all. So I want to essentially draw something. Draw a little square around when we click. See if it matches any of the objects. Is that the most efficient way of doing it? So we'll create a little function. How do we know? You know what? What we've got to do is actually we've got to loop through all the objects on the screen and see if the coordinates matched one of those. The other big question we have is how are we going to decide what appears where on the screen? Now, I've got a load of cubes spinning around at the moment, but if we think about it, we've got objects, characters, and exits that all need to be interacted with. on top of that, we're going to have other UI elements. So I'd really like to make something procedural so that it's, and then again, you kind of want consistency between locations, right? I was actually thinking it would be nice to sort of theme it so that depending on the location you've got, you might have different levels of color. And as you transition from location to location, you get that sort of sense of travel as the colors sort of shift. So that you could have a dark area, a light area, green area, high-tech area, whatever, just based on the theme. Well, so we'll just do a little check click function here for now, right? So what's this going to do? It's going to loop through some objects. So eventually that might be whatever objects are we decide to create on the screen. Try to match against the mouse location. So we're going to pass in the mouse, we'll just call it mouse XY. And if we match, then what do? Let's shrink the target. In fact, actually, you know what? And let's just delete the target object now. What we really want to do, though, is have some sort of sense of hovering over it. So we don't just want to get our click. We want to check the event position constantly. You know how slow and clunky that would be. So the input event. Yeah, we'd have to match it against event mouse. So we'd have to put in here, if event is input mouse motion, then we want to check to see if we encounter an object. That would be better rather than a click, because now we can animate as you move into an object. So what we'll do is actually we'll loop through the objects, try to match against the mouse location. And if we match, then we're gonna what's the word? Gonna expand the object or something. We can have a state, right, of the object. So we can have a state, animation state for the object. That'd be cool. Yeah, let's do that. So what we're going to actually have to end up doing here is defining our exits. So at the moment, our exit is a node. It would make more sense if the exit becomes a 3D object on our screen. Then we can give it properties relating to what we're going to do on the screen without having to like create another object that maps to the exit object and so on, I think. All right, so let's loop through our objects on the screen based on the current coordinate. So this function check click, it's going to go, let's say it goes here, and it's got actually just check location. We'll check mouse location. But you know what? It would be better just to call it what it is. Check hover, right? And we're going to pass in our event position. Right, so check if mouse over object. Where's the error? Line 126. Okay, so what we're going to do, we're going to loop through our existing objects. Easy way to do that would be to group these up for now, because our exits are grouped, everything else is grouped. Groups, manage groups, group editor. Never used groups before. Just hit add here. Add. Oh, okay. Cube. Add a cube group. So mesh instance 2. We need to do it again. Oops. Cube. Sorry. I think that's right. I've only done it programmatically. You can see we're getting this little thing up here. Node is in one group, yeah, so we're doing it right. Add, paste, add, paste, add, paste, paste, add. All right, so now we can loop through our cube group. Now our exit code does just that. So for exit in location node get children, no. Group, add to group exits. Oh, there we go. So here we remove all exits by connecting to get nodes in group. So we use that code here. But to loop through our objects, we just need to get cubes. This capital C. So for each cube in get tree, get node in groups, cubes. Right, so if I run that, check hover isn't declared yet. Check. If I run that, as soon as we run over a, well, there we go. You know what's going to happen? Q3 is like it's a way of removing the node from our tree. So if I free this up, that means if I'm not actually matching. It just means it's going to delete everything straight away as soon as I move my mouse. Let's try it. Oops. Am I on that scene? Spatial. What's the game scene? Yeah. Right, and move. Oh, we're still here. That's weird. Oh, hang on. Doggy's barking. 2 seconds. Maybe this doesn't work. Should have just deleted everything straight away there. Just do a little print out here. Print. Test. See if it actually makes it in. Don't see it anywhere. And if we print mouse XY, and if we get rid of this printer, run that, see, yeah, it's going into that loop, but it's not finding a group of cubes for whatever reason. It could be that our tree's wrong, so let's have a look. So our code says get tree, get nodes in group. And if we go to our remote, tree is root. So I think we need to add a get current scene first. Does this work, perhaps? Let's check, make sure we've got. Oh, cube. Cube. There we go. Right, now it will delete them all. Boom. And now it can't rotate them, obviously, because they've been deleted. So we don't want to do that. Okay. Fabulous. Works. So let us trigger an animation on the cube. So if these were objects, let's say this was an exit, then that would make more sense at this point, because at the moment we're just messing around with a pure 3D object, whereas an exit can have its own properties, its own scripts, its own methods, and we want, we've just referenced this object, this 3D object on the screen. So we want to hook into its methods. And I know we're trying to do a proof of concept here before we connect to it, but exit.gd is a much better proof of concept than our cube at the moment. It's a bit of a chicken and egg situation, because it requires quite a lot for us to hook into our exit GD, and it may well break our existing select system. I mean, if I change this node to a mesh instance, should I even do that? What happens? Can I actually run the game? Straight away, it's like, hold on. Visible already exists. It's true, it does. That's cool. It's obviously a mesh instance, whether it's visible or not. Existing information. So there we go. Oh, well, that seems to be okay. Oh, yep, cool. Play the game. Nope. Script inherits from type mesh instance. It cannot be instanced in object type node. So we're trying to add exits and remove exits. But if we look at our game scene, so let's just change that back to node. We look at our game scene, shock horror. Can't have a mesh instance under game because game is type node 2D. It's a 2D game. Have a weird mesh instance there. So does that mean we have to completely redesign the architecture? Maybe. No biggie if we do. I don't think it's a massive amount of changes. Just want a bit of test this, start building up this interface design whilst keeping in mind not redesigning the wheel so much. So, okay, let's say, for example, that we instead use an animation player. Actually, you know what? Nope. I'm just going to change the size of this mesh instance. So this mesh instance has a scale. Let's look at the properties of mesh instance. We got a getter and a setter for scale, maybe. Nope. Does not. Okay, you know what we're going to do? We're going to add a tween. Tween. And we are going to mess with our mesh instances scale using a tween. Get rid of all these tabs I don't need here. Okay, so at the moment we're not matching to see whether we've found anything yet. So we're not going to queue free. I'm going to step through all these cubes. We're going to get the translation, is that right, of the cube. I'm going to check whether it matches XY. So I'm going to do a check collision. And we're going to pass in target. So we'll pass in object 1, object 2, and distance. Should we do radius? No, we'll do a square. So do like the, yeah, we'll just do a square. What length? So checks for a collision between object 1 and object 2 based on a given square. I think that's right. So oh, you know what? This will be mouse X square. Let's say. Okay, so we're going to draw, if we imagine the mouse XY as a point, object 2 is our object, and we're drawing a square around it. So our square is a given height, width, length. Right, so what do? So we want to check. Okay, so here's our point. I'm just going to do it visually on paper here. Should set up a little paper camera. So I've got a point, our object. Our object has a square around it. Our XY point 1, 2. Checking it on the. We're basically saying, is it within this on the X? Is it within this on the Y? Probably a really good formula for this. Let's have a look. Colon here. Collision formula square. Okay. Let's have a look. Shortcut for solving elastic collisions. Formula for collision. No. 2D collision detection. Two rectangles are axis aligned. That's what we want, except one's very small. Yeah, right. There we go. Axis aligned bounding box where rectangle 1 is going to be like the mouse pointer. So it's just a point. It'll just be width 1 and height 1. Okay, try it out. So, you can do circle collision as well. That'll be better, I think. Much prefer that, because I imagine these actually not being squares, but they could be. Just seems nicer to have a circle collision. Square seems a bit crap. Cool. Okay, let's try that. All right, so let's translate this into something that makes sense. Okay, so our mouse XY is going to have a radius of 1. This will be mouse XY dot X, right? And this will be mouse XY Y. Oops, you know what I've done wrong there? Rather than rip this code out. There we go. Replacing these values. So X equals mouse XY X position, Y equals mouse Y Y position. Next, we need the translation from the object that we're looking at. So, so we can define what our radius is going to be. That's up to us. So we'll call it radius here. And check for collision between mouse XY and object based on a given radius around the mouse. Right. So actually a radius around the object, isn't it? So this radius here shall be a radius, and this will be object dot X. This will be object dot Y. We'll just call this object translation, actually, right? Let's be literal about this, because we're going to get an XYZ from here. No, wait, we're not. Are we? No, we're not. We're getting the Where did I put it? Did I delete it? Like I did delete it. Checking the hover position. Oh, there it is. Unproject. So we are getting an XY viewport position. But it would be better to do that in the function, right? So we are passing in an object. We're looping through objects. Then we're going to get var object viewport xy equals that. Pass in the object translation. Let's not call it. Let's call it target object. Obviously, object is a bit of a reserved word there. Okay, cool. So we're getting the object that we're looking at, XY coordinate in the viewport, creating a circle around our mouse, very tiny one, creating a circle of whatever the radius we decide it to be around our object. Then we check. So that should just work, right? So we get so the diameter x circle 1 minus circle 2 to y dy dx. I'm not sure what that's distance. Maybe distance x, distance y. Yeah. And then it calculates the total distance with this formula: math square root of dx times dy. Dx times dx plus dy times dy. Oh. If the distance is less than circle 1 radius plus circle 2 radius, this is correct. Collision detected. All right, print collision. All right, we're passing what? X isn't declared in the given scope. It will be when we pass it in. Is it because we define it in the function? I'm going to have to find a script where I do that. It's colon. So we have to go mouse x, y, vector 2. Capital V. Oh, it's like, what's X? How do we define objects like this? Like JavaScript or something. God's sake. Obviously, semicolons can't be used for starters. I think that's a dictionary, right? So dictionary. And speech marks around the value. Best way to do it? God, makes you miss JavaScript, that's for sure. Right, okay, so it's like some sort of, it's a bit like Python. I don't know much about Python yet. Should really actually do a little Python course, just get some fundamentals here. Anyway, so apparently, declare this this. Be happy. Circle 2, same. X. Okay. Square root. Cool. Alright, okay, now, obviously I don't think that's going to work. Maybe it has. Shouldn't. So, let's just try it anyway, see what happens. Oh. Okay, I mean, it's a test coming out. Right, okay, so I mean, it's not got into the code yet, so but, it ran. So check collision. So now we've got to pass in the mouse XY, right? So that's XY. So in. Target object is cube, and the radius will go for 10. Oh, you see that? So down here, we've got our output. So it's so small, it really is so small. We're just going to hide the mouse XY printouts here. But it looks like we're good to go. We're cooking on gas. So now when I hover over any cube, I should see the word collision pop up, right? Boop, collision. Now let's just print out, like, what object are we colliding with? So we've got a reference to cube, we've just passed it in. So we'll say collision with cube.name. Whatever the hell that cube is. Oh, it's target object.name, right? That should be a little bit more relevant. Collision with mesh instance. Mesh instance 3, 4, 6, and 2. And of course, because we've got a reference to these, now we can do things to them, right? So, it's pretty cool. So we now have mouse collision detection. Happy days. So let's do something to it. Let's make it, let's just say, no, let's just shrink it, make it disappear for now. It's for some sort of effect. I'd rather it was like some hover effect. How would we do a hover effect? We've got to have some process that checks to see whether you're colliding, whether it really will want the object to say, I'm being collided with. Then the object can decide what to do. So with signals, we would want the object to have some sort of method to say, am I being collided with by the mouse? That would be the best way. Then all our logic can come from the object in question. It is our UI at the end of the day. You know, what do we want to happen when you hover over this object? We might want it to give us our options. Maybe we want to click it before that happens. Maybe we want to tell us what it is, but maybe you should already know what it is. Maybe we should have a little line that says, this is the TV, or draw something from it. Let's just do a little mess around anyway. Target object dot scale equals vector 3 on 0.5. Can we do that? Make it big. It'll make it bigger every time I move over it. In fact, it'll just explode, right? Wah! Whee! Woohoo! Yep, okay. Actually, no, it'll just set that scale forever, right? It won't do it again. It's just setting a scale to that. You know what we could do? So we can say else. There you go. We just made a toggle. Not great though, because obviously now we're targeting the object from this other script, whereas we really want the cube to do it itself. Wow, okay. It's not right. Apparently the scale of the objects is not currently 1. Double look. Oh, scale 0.2. Explain something. Funky tunes. Who are these tunes by? It's Patrick Walker from Edinburgh. Irradiation SD remixes. Put up a bit. Cool. So we'll just make a little subtle difference here. Have it expand slightly when you move your mouse over it. Here we go. Pop and pop. Pop, pop, pop. So let's get our circle a little bit bigger. So we're going to change the radius to, let's go for a 30 pixel radius. So we're now creating a 30 pixel radius around our cubes. That's much nicer, isn't it? Look at that. And if we go over here, beep, shouldn't matter where the camera is. It's always going to be relative to the screen. We could have this pan over everything and be able to see exactly what's going on. All right, getting there. And now we can also use our click. So we can check for a collision and then click, and what happens? I don't know. I'm thinking maybe we do the verbs appear in a circle around the object. Oh my God, more coffee. Thank you very much. Oh, thank you very much. What, no Oreos? So, that's pretty cool. I think the last thing I'm going to do right now is just put an object name under these. Let's see if we can get some sort of name label under our object. Let's hover it there. Would we do that in 3D? I don't need a... Can't add a label to one of these, can we? What on earth would that do? I've got a canvas layer. Let's just try and see what happens. Exit 1. Exit 2. Nah, I mean, this doesn't make any sense, right? They're just appearing up here. Because they've got no position on screen. So what would we do to make those labels line up? Because they're 2D objects in a 3D world. So we'd have to match up their XY coordinates to like an offset of our mesh's location. So if we created a script here called float labels. Let's switch to our coding view. All right, so we're making a function called float labels. What's it going to do? We're going to pass in a object, and we're going to pass in a label, and it's going to float the label to a position offset of the object. So let's say all our objects have this kind of text floating underneath them all the time, and it's 2D text, it's not 3D text. So we're just going to set the position. So label dot, you know what? There's a command for this that I don't know because I haven't really done any 2D coding yet, as much as I'd like. Look at the label code. What do you know? The label doesn't have any XY property. A label has a grow direction. It doesn't seem to have like any sort of point on the screen, or does it? Anchor, could it be? Anchor? Control. Okay. Let's just try that real quick. So if I change my anchor left to... Ooh. What is that though? Look at that value. Anchor left. Anchors the left edge of the node to the origin. The center of the end is right. Okay, let's just say Godot position text at coordinates. Let's see if anyone's got a better solution. Like extracting grid coordinates from mouse cursors. We might have to do that at some point. I expect we're going to have to create some sort of grid on the screen, and decide where we're going to align these objects. So each property, each exit character, and so on has like a unique grid reference. So when you're designing the locations, you can say, this is going to go here, this is going to go there. How do I center a label inside a node? Sure how to do this. So, position text in viewport. Flat text in a 3D environment. There's a GUI in 3D demo. You'll find the project manager's template tab. Should look at that. One called 2D in 3D demo. Viewports. Don't know if that's the right way of doing it. I know the one that is. I think that's like a table tennis game. Come any time you want to do something different, none of the game engines ever have a facility for it. Surely floating text would be like a pretty standard thing. Okay, what is a viewport? We have got a viewport, we're using it. Creates a sub view into the screen. Which is basically what we're doing with our camera at the moment, presumably. Viewport creates a different view into the screen or sub-view inside another viewport. Children 2D nodes will display on it, and a children camera 3D node will render on it too. Let's turn down the music a little bit. Spicy. So 3D world of viewport, parent, find world 2D, turn the active 3D camera, get the canvas transform, rectangles. Can I draw text on the screen at a position? let's look at Godot's canvas layer. Object, see what we can do with that. Because I know you can draw stuff. Maybe you can write stuff. Tutorials. Let's just look at draw. It has nodes to draw sprites, polygons, and particles. For crying and fear, angst, and rage, because a node to draw that specific sound that does not exist, it would be good to know if it's possible to easily make it a 2D node. Just drawing manual in a node is really useful. Canvas item derived nodes. Still not what I'm after. Can we position a control on the screen? Maybe we can position something that becomes the parent of so there's a control node. Enable into the control node. What have we got? Same thing. What does this mean? Okay, so where one is 100% of the screen. I think we might be able to work with that, right? So 0 is far left on the X, and 1 is pushes it all the way to the right. We're gonna have to translate our create a kind of fake positioning for our text label. Oh, we do like a challenge. All right, try it. So we're gonna have to do this every frame that the screen moves. So float labels is going to have to run every time we move the camera. So that's going to be input event motion. So we're going to have to update label positions. Did we pass anything into float labels? We did. Maybe we don't need to. We're just going to loop through every object. Let's loop through all our objects. We're going to do the same thing we did here, right? So, so here, looping through. We should actually see all this stuff here, changing the scale. We should do that here. Check collision should just return true or false. I'll just do that real quick. Otherwise, it's not really well coded. So we'll just return true. Over here, so else, that will just return false otherwise, right? So here, we'll just set our collision equals false, and then we'll save the result of our function to check collision, and then if collision, why can't I spell collision consistently? If collision, do that, else do that. Target object is now cube. Should do the same thing. Pass error expected block. What's that down here? Probably. Yeah. Just double check that code works. Oop, still got an error. What's that? Cube.scale. Oh, of course. We're out of this loop now, right? Put that inside the loop. Better, right? Which now means, of course, we can use check collision for literally every 3D object in the game that we might introduce into our viewport. It's great. It's great. So float labels. So now we're going to step through our cubes at the moment. So for cube and get tree, get all the cubes. We don't need to check for a collision anymore. We're going to set, how are we going to do this? Doing a float label. So it's based on mouse movement, not based on a hovering position. Okay, so I think maybe we need to we need this function again. Gets our cube's unprojected position. So for our cube, so we're gonna we'll have to set this variable up here. We're gonna use it multiple times. Redeclare a variable, which we'll call it object viewport xy. Fine. But now it is cube translation. Okay, so we're stepping through our cubes, and unindent that. Stepping through our cubes, and we're saving out our XY translation. Great. So that's fine. We could print out cube.name is located at object viewport XY. We should get spit out of every single object here in our loop. Yeah. And they change if I move the mouse, right? They all update. It's just too much text because it's trying to spit out every single location update. So that's fine. Now we need to work out, if we can, we need to adjust the label anchor. I mean, I don't even know if it's going to work just updating a label anchor. I'm just going to try and just throw it in here. So label, we need a label 2. Oh no, actually, no, we can call it label. We use the same name each time. It might be useful. So it's mesh instance label. So mesh instance label dot anchor left. So it's a ratio of 0 to 100. 0 to 1. We can times that. So okay. So that's going to be our current anchor left is our x, right? That's going to be our x coordinate divided by the length of the viewport, right? So our whole viewport, if our whole viewport is 1,000 and we want our label to be on the far right, it will be 1. So that would be 1,000 divided by 1,000. So how do we get our viewport resolution. Get Godot, get viewport size. Let's see what that comes up. Screen dimensions. Jeez. That looks better. Size of the viewport. I think that's better. .x. Yep. See what happens when we do that. So what we're saying there is we're gonna float this label. Who knows what's gonna happen? Actually, to be honest, I don't care. As long as we see some sort of shift here. No, we're not seeing any such shift. Non-existent function get rect. Okay, hang on a sec. Doggy's moaning again. All right, so wait a minute. So get viewpoint works, but get rect doesn't. If I do that, you're gonna give me some options here. Get viewport. Camera, child. I could be doing this forever. Quite a lot of stuff. It seems to be showing every single method inherited by that class as well. Godot, get viewport width. Screen sizes. Now I'm not going to watch a video. Let's try that one. 2018. One year ago. Get viewport.size. All right, let's try that. Size. Yep. Okay, but isn't that going to just return? Isn't that what we just tried? Float and vector 2, yeah. So that should be a .x. So, all right, cool. Oi, look at that. It works. The exit 1 is getting manually positioned based on the position of my camera here. So it's a bit weird. Look at that. It's not perfect. It's very clunky. Technically, works. Okay, so if we wanted to do this on every cube, now we've got a link to the cube, so we know the object, which is mesh instance, so now we just need to get the label under it. So if I add a few more labels here, duplicate this one, stick it here, name it label. Of course, again, we would dynamically do this. Wouldn't be creating the tree like this manually. Cool. Let's call this a T. We'll call this plant. We'll call this cheese. We'll call this Graham. Call this God. Call this one door. And we'll call this the toilet. Okay, great. So all our mesh instances have labels. So that means we can do a get node, right? Which allows us to build up a query here. So we can say mesh instance. And then we can add plus. Hang on, no, we don't want to do mesh instance. We've got cube, right? We want to get the sibling. So we want to get sibling. No, we want to get the child, sorry. We want to get the child of label. So Godot get child. How to get a variable from a child node. Nope, that's not what I want. How to get a child node. Get child. Get node, get any node in the tree, but not only the children, the name is accurate. Get child is a direct reference to the nodes. There's no search needed. What? Yeah. What would get child do then? Would it get multiple nodes? I'm just going to check if there is a get child. Help, search, get child. There is. Get child returns a child node by its index. Right. So it's always going to be 0 in this case, right? This is like such temporary code. So it'd be cube dot get child, and the index is going to be 0, right? So now we've got a reference to anchor left. So now this will move all our labels based on the cube position. Oh, yeah. For whatever reason, toilet. I don't know. Toilets. They do seem to be adjusting somewhat strangely. Oh, of course, it's because of the distance, how close it is to the camera. They're actually moving in parallax, so that's pretty cool, I think. Let's try and align them with the objects now on the y coordinate. So, good thing about this is we should only ever have to do it once, right? Shouldn't have to do it for every object. You know what? I'll just do it for now, but we would probably do it like, because we're never going to move the camera up and down, or maybe we will. Who knows? You know what? Let's just do this anyway. Anchor right? No, anchor up. Label anchor top. Anchor top. Same thing then. It's going to be based on the Y and the height of the screen. Now they should appear on the objects themselves. Yeah. All right. Cool. Nice to see we can identify objects now. Now we need an offset. So we're going to offset them. Now it looks like the connection is based on the top left corner of each text label box, right? So it'd be nice to center them under the objects. The only trouble is we don't know how big the object is. Bit of an issue there. Don't know how we get around that. Anyway, let's just try this for now. So how could we get the size of the object, I wonder? That's a whole nother question. Okay, so our offset. So we're going to set an offset. Go up here, set an offset. So var label offset equals vector 2. So we'll offset. Shouldn't really offset X, but we're going to anyway, right? We'll offset like, maybe we should offset based on the size of the string. Does that work? How do we know the size of the string? Number of characters. Can we convert that into some sort of... Oh, you know what? Stupid. I just need to go into label on our scene here and just go align center, right? I think, right? That should automatically set our like point, alignment point at the center of the text. Then all we then need to do is change the Y offset, right? But then that's going to be weird because we don't know what the height of the object is. So if it's really close to us, the text could appear inside the label. I love the thought of, actually, you know what I'm going to do? Oh man, I wish I'd not just done all that, because it'd be nice to have a custom font. I'm just going to change this font here. Font font, dynamic font, click font. And let's go to fonts. Stick a font in there. Is that the font we wanted? It's the font we'll use. Yeah, the rich text had stroke and stuff, didn't it? Do we have anything for that? We do that? Font outline, here we go. So we can set an outline of 3 pixels in black. Font size to 20. There we go. We'll even put some min-max and some filtering on it. It's only for one of our labels though, right? So in our script, so our label offset Y, we're going to position it 30 pixels below. I've got an idea. Right, what we need to do is, because we can't tell exactly where or how big our image is, we draw a line away from it, like in Sean's little picture that he did for us. Wow, Sean's already solved it. He just didn't know it. So we need to draw lines to the points. We need to have some sort of system for drawing lines using our labels. So our line will point to the center of the object. But now it doesn't matter how our text is associated with it. That'll do it. But anyway, so for now, I'll just set a label offset of Y. Go into our tunes, stick some more tunes on. Get rid of the blank space. So when we're positioning our Y, we want it to be object viewport XY plus or minus our label offset Y. Let's do that in brackets so it gets the order right. All right, try that. Oh no, it's plus, isn't it? Yeah, we've moved it up rather than down. Definitely not enough though. Get 60. That's a bit weird. Doesn't line up right. Kind of some weird stuff. Even looks like it's going up and down a little bit. Bizarre. Maybe we should just position the... no, this is the trouble. So we're positioning text based on a scale of 0 to 1. But look at toilet. How is that? I don't understand how that is in relation. Look at cheese. Cheese is so far off when we go in that direction. It's like it's not taking into account the perspective. You can see a 3D programmer right now to be throwing his pen at the screen saying, you're not taking into account something. Perspective, perhaps? Cool, though. I mean, it's a nice starting point. Now, if we just draw a line from the center of the object to... Do we know where the center of the object is? I guess we do, right? Because we're drawing a block around it, so... I mean, if I just change this at the moment to be the center of the object... Oh, we can't, of course. We're still translating anchor left and anchor right. Anchor top. Interesting. It's interesting. I wonder what that actual point means then. Is it the center of the cube? What if we make our cube smaller? What if we move our camera back? Let's just have a look at our 3D scene here and see what happens if we move all our labels back there. You know what I love about this is it looks like the labels actually, because they're labels, they're buttons, right? So they actually connect. They won't. And the only reason toilet's overwriting it is because we've changed to custom font, but they won't. They're designed not to go over each other. They actually interact because they're UI elements. They're not really being drawn to the screen. But that's still working really nicely. Look at that. Except they can't seem to hover over T. I wonder if it's the word T that's getting in the way. Oh no, it's just I'm doing both of them at the same time, right? Well, that's a bit weird. We should only have one active object. This is why, though, we want to make sure that the positions of these objects are kind of spread out. Oh, you can pick them from here. That's cool. Bring them right in. That again. Cool. Well, you know what? We've made some progress. It's 10:30. I'm half an hour past I'm really sleepy tonight, but considering, done pretty well there. So I'm happy. Wondering if I should start committing this code. I think I probably will. So let us import. So created cubes, collision detection, and what else do we do? Labels, some kind of labels. We're just messing around though. We're just trying to come up with something cool for our GUI. So tomorrow, I'm going to try and get Callum, see if he can, because he had some good ideas about what he wanted to do with this. So I don't want to get blinded by what's possible. I want to focus on what we want to do. So I think we've got some core aspects there. We've got the hover over and positioning. So we can now start really building on that. So if you joined me, I hope you enjoyed the stream. If you're watching later on, thanks for watching. Don't forget to like and subscribe if you made it through this far. Congratulations. And I'll be back tomorrow at 9 p.m. BST for a Sunday special. All right, guys. Have a good night. Take care.